Hey guys, today we are going to be practicing with polar coordinates. We're specifically going to look at first how to graph them and then how to represent them in different forms. So if we look here, we're going to plot these first 4 points. I picked 4 so you can see that there's different scenarios that you're going to come across. So this first one right here, 3, 270, this represents your directed distance and the angle represents your directed angle. So even though it's written as r theta, I graph it theta r. So I first find the angle and then I find my directed distance. Each of these rings represents my directed distance. So I have 1 through 6, and then each of these represents my angle. So the first thing I'm going to do is go to 270, and then I go to 3 right here, and this right here is my polar point. Then I'm going to do my next one, which is -2, 330. So I go to 330, so I'm right here. And this is how I think of it. I don't know if this is exactly like mathematically correct way of thinking it, but I feel like this makes a lot of sense. So my directed distance is -2. So instead of going towards 330, so like driving towards 330, I think of it as like you're reversing 2. So instead of going towards 330, I go back to 2 on 150. So again, if your r is negative, and this is only if your r is negative, if your r is negative, you go to that angle, and then instead of going towards that angle, so the positive distance, you reverse back into the other quadrant. The next one we're going to do is 6 pi thirds. I wanted to throw some radians in there so we're just familiar with them. Remember, pi thirds is 60 degrees. So I start at 60 degrees and then I'm going out to 6. So I'm going to be right here. That's my polar point. And then the last one I'm going to do is -1, -60. So -60 is the same as 300 in the positive direction. And then again, it's negative. So instead of going forward, I reverse back. So I reverse back 1 into -1. And then those are all of my polar points. That's it. That's how you plot a polar coordinate. Now the other thing you need to know how to do with polar coordinates is represent them in different ways. So this would help you if you were, say you had B and you were just super confused on the positive negative. You could convert this so that 2 would become positive and you could figure out where it was. Likewise, this one you could convert both of these so they're both positives if negatives are throwing you off. So the formula for converting them is we keep r the same for this first formula. So we keep r as 6. And then if we want to change the angle, we use this formula. So we plug in our angle, which is pi halves, and then we add it or subtract it to 2 pi n. And n represents the integer set, so you could do positive, negative, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, and so on infinitely. So I'm just going to plug in 1 because I'm just trying to show you guys it can be represented in different ways. So I'm just going to plug in 1. So that's going to give me 6 comma pi halves plus 2 pi. 2 pi and pi halves cannot be added because they don't have common denominators. So I am going to multiply this by 2 over 2. So that's going to give me pi halves plus 4 pi halves. So it's going to give me 5 pi halves as my angle, and then r stayed the same. So this is the same as 6 5 pi halves. And again, this angle will change an infinite amount of times because it's a coterminal angle, so it's just going around the circle an infinite amount of times. That's where the 2 pi comes from. So that's for the first one. The second one here, if I'm given r and 45, I'm going to try this formula right here. So if my angle was positive or negative, I can plug it into this second formula and change its sign. So since it is positive, when I plug it in, it's going to become negative. Again, if it was negative and you plugged it in, it would become positive. Then my theta is 45 plus, and then I'm going to pick 2 for my n this time, plus 1 times pi. And then again, I just simplify the formula. However, one thing I need to keep in mind is that pi in degrees is 180. And since this is a degree measure, I need to use degrees. So this could also be 180 if I'm in degrees, and this could be 360, again, if I'm in degrees. So then I'm going to have -4, and then I have 45 plus, I do 5 times 180. 5 times 180, I did not grab my calculator like I should have, so let me do that real quick. That would be 900. So that is going to be 45 plus 900, so that would be -4, 945 degrees. And that's it. These just represent the fact that we can use coterminal angles to change the way we represent our polar coordinates. And that is all you need to know with the basics of polar coordinates. Thank you guys so much for watching my videos. If you want to get better at math, subscribe to my videos here. If you want more information on math, click on my website link here.